Okay, this is sample problem 18.10. The equilibrium constant KSP for the dissolution of silver chloride in water at 25 degrees C is AgCl solid converted to Ag plus the silver ion. We call that aqueous plus the chloride ion, Cl minus aqueous. The value of KSP is given as 1.6 times 10 to the minus 10 at 25 degrees C. Calculate delta G naught for this process. The relationship between the standard free energy change, delta G naught, for any reaction is minus RT times the natural log of the equilibrium constant for that process, which in this case is KSP. Okay? So all we need to do to find the value of delta G naught is just go ahead and put in those numbers. Now, when we do energy calculations, and this is certainly an energy calculation, the value of R is generally 8.314 joules per kmol. The value of T needs to be in Kelvin. 25 plus 273 is 298 Kelvin. And then the natural log of KSP in this case would be the natural log of 1.6 times 10 to the minus 10. Now I will point out that sometimes R is given as 0.008314 kilojoules per kmol. So that would be perfectly fine to use that value in here as well. You'll just get the answer in kilojoules per mole as opposed to joules per mole. Okay? So the only real trick to this is just being sure, let me just go over the units. Kelvin will cancel and you'll have joules per mole. Joules per mole. The only trick here is just make sure you know how to use your calculator, taking the natural log of the KSP. 1.6 times 10 to the minus 10. The natural log of that is negative 22.556. Negative 22.556. So that would be minus 8.314. 298 times negative 22.556. And then that's going to be in joules per mole. Okay? Now, if you take a look at these numbers, you're going to get a positive value, right? Because a negative times a negative is positive. So that tells us it's non-spontaneous at this temperature. Now, at a different temperature, it might become spontaneous possibly. Let's see. Well, no, it doesn't look like it would work out because the temperature has to be positive. This negative is in the equation. If KSP is less than 1, we're going to get a positive value for delta G naught. So even at high temperature or low temperature, this appears to be a non-spontaneous process. Okay, so we've already got the value of LNK right there. So let's just multiply it by the 8.314 and then the 298, and you get negative 55,883. So I'm going to round that to 55,900. So you get 55,900 joules per mole. Now keep in mind, generally the numbers that we quote for delta H and delta G are in kilojoules per mole. So if we'd used this, that would have given us kilojoules per mole. But let's go ahead and do the conversion from what we have here. One kilojoule is 1,000 joules. So you get 55.9 kilojoules per mole. Okay, there's your delta G naught. 55.9 kilojoules per mole. Positive, meaning it's non-spontaneous. So when you get an equilibrium constant that's less than 1, you're going to have a positive value for delta G naught. So under standard conditions, it's a non-spontaneous reaction.